Hello. Welcome to your favorite class in your favorite semester of all time. I am your professor, Mr. Nicholas Moore, and today we are going to talk once again about objects. Oh my goodness. That doesn't sound like my condenser mic. Maybe it is, though. Testing, testing, 1, 2, 3. Thank you! It seems a little echoey. Not sure why. Sure why it should be echoey this morning. That's different from, like, usual, isn't it? Oh. It just clicked over. That was weird. Yeah, because it just switched mics. Oh my goodness. Okay. Nice profile shot. Man, I need a shave. Okay. Okay, well, at least it happened at the beginning of class today instead of in the middle of class today. Alright, well, as long as it's low noise. The rain in Spain falls mainly on the plain. She sells seashells by the seashore. The quick brown fox jumped over the lazy dog. Well, it sounds a little, like, reverby for some reason or another. I'm not sure why exactly, but, well, what are you gonna do? It is the proper microphone, so... Oh well. Do I have a... Can I do something here? Add filter. Probably not good to mess with these sorts of things on stream. Maybe we can just move into our lecture material for today. Hi, guys! Man, viewership is, like, super low. Kind of depressing, really. I hope that means that everybody is watching these lectures after the fact, and that people have just, people haven't just stopped watching the lectures right when we reach, what's arguably the most important part of the entire course to actually pay attention to. Because, even for people who have done programming before, who would have been, highly advantaged during the sort of first half of this course, this is the material where that advantage will begin running out for people. So you don't necessarily make it to classes when you do, like, when you're messing around doing intro programming tutorials online in the way that people do. But anyway, so when we were talking last, we were talking about inheritance. And just to recap the idea of inheritance, when one class inherits from another, it has all of the properties, all of the attributes, and all of the methods that are described in the class that it's inheriting from. So our example that we were using was a quote-unquote colored point class, which extends our point class, which is the point in Euclidean space. That's generally the terminology which is used as well. When one class inherits from another, it is said to extend that class, which is a good way of thinking about it, because what you're essentially doing is you're adding a bunch of definitions for various things, or added attributes, that you're building off of the existing class. So, you know, that's it's a good thing to know how to do. So, with respect to inheritance, we were talking about how you can tell whether a class inherits a particular class by using the isInstance method, or function, sorry, pardon me. Using isInstance, one can tell... Oh, that's from Mark. Apparently, there was assignment 7 didn't quite make it to Avenue. I just messaged Mark, and not that Mark, the other Mark. It should be up there now for everybody. So if anybody would wish to confirm that, I would appreciate it. Yeah, I'm not sure. Oh, is my video stuck again? What the heck? Jeez, man. Technical difficulties galore. It's a funny face to be stuck on. Yeah. Okay. Testing, testing, 1, 2, 3. Testing, testing. Test. Yep. Okay. Alright. Oh my goodness. What a pain in the keister, I tell you. Like, what is even the point? I would rather be teaching in person. But anyway. So isInstance can tell you if a particular object inherits from a particular class, which is sort of distinct from type. Type will only show you what the sort of most specific class that's attributable to an object is. That's another way of thinking about inheritance, is classes that inherit from other classes are more specific than the things they inherit from. So, yes, we also talked about multiple inheritance, which is, you know, if you get inheritance, multiple inheritance isn't too much of a stretch. Basically, the idea is that a class can inherit from more than one other class. So, if we wished to take the color properties and methods associated with the color property and abstract that out, make it into its own class so that it can be used by other classes, not just points, like, say, lines or figures, we can define a special class just for color, and then we can combine point and color classes to make a colored point class. And you can see that we are accessing both the constructors for the point and the color class within the constructor for colored point. Hopefully this is all reasonably straightforward. This encourages code reuse, which is, generally speaking, the goal. So let's talk about abstract classes. So the difference between a class and an abstract class is kind of purely intellectual, shall we say. There's nothing in the class in code that distinguishes an abstract class from a regular one. It is entirely in how the class is used. So, an abstract class is a class that has only been created to be a base class for inheritance. It serves no other purpose than to be inherited. If you were to go for a physical analogy, the idea is that it's a class it's a concept that's sufficiently abstract as to lack physical manifestation. So, one might say that the concept of object lacks a physical manifestation, right? You wouldn't say that an object exists just as an object. Anything you call an object can be subject to further classification. So, the idea of an object is an abstract category, right? It doesn't necessarily pertain to any particular physical implementation. It's sort of in the same way that you can imagine a chair that is just a chair. It's not a dining chair or an office chair or a living room chair. It has only those properties which one associates with chairs, and therefore it is a sort of physical implementation of a chair. Whereas, if you go one or two levels above that to, physical object or, even object in general, you begin to lack physical manifestations. So an abstract class in programming is that sort of idea of a class which is never meant to be instantiated. That's another way of thinking about it, is it's a class which, in all likelihood, will never be physically instantiated in memory. It will never have an object produced from it. Objects will certainly be produced from classes that extend this abstract class, but the abstract class itself is never intended to be used sort of as an object. So that's what an abstract class is. In our previous example, it's difficult to understand what a color would be in the absence of something that is colored, right? It's an adjective, not a noun. That's another way of thinking about it. So because it's an adjective and not a noun, it, you wouldn't say color exists independently of the sort of carrier substance, if that makes sense. Like, red paint is not red. Like, red as an abstract concept doesn't really exist. It only exists insofar as paint is red, right? Or, a ball is red. So, yeah. Anyway, so that's a little bit of an idea of abstraction. Let's see. What? Come on! No data. Did it? Oh my god. This is annoying. Alright. Is audio working? Did I lose any of the previous thing I was saying, or are we okay? Okay, we didn't lose anything. Aside from time. Okay. Holy. Okay. Holy smoke. What a hassle. So, anyway, so that's abstract classes. So, let's move now into some examples. We've got two examples that we're going to go through here. One is a quote-unquote birthday calendar, and the other is a mean calculator. Not mean as in it insults you whenever you try to calculate something. It's calculating the mean in the statistical sense. So, birthday calendar. Let's get a description of this problem. Our task is to design a birthday calendar with the following operations. This, incidentally, is structured reasonably similarly to how you would see an assignment or a test question structured. Generally speaking, we'll tell you what properties, what attributes it needs to have, and what methods we expect you to program for it. So, we need the following operations. Clear, add, contains, and birthdays. In various places, we take both names and dates. This requires a data structure with entries for names and dates. The data structure is shared among the operations. A class allows us to encapsulate operations on shared data structures. You can imagine that if this were some sort of web interface, for example, that you would have buttons that would do each of these operations. So, let's take a look. Let's... Yeah, I know, it's just... I didn't spend all of this money on good broadcasting equipment to have it constantly fail. It's frustrating. So, anyway. Let me just comment out a little bit of what we were doing last time. And let's start afresh. So, let's make a new class. Class. bdays. Extends not object or nothing. We'll need to have an initializer, of course. Define init. We'll take self automatically, and we can add whatever we need later on. Let's assume that we're starting with a blank birthday calendar. So, we now come to the question of how, in particular, the information that we're storing inside of the birthday calendar will be stored. Now, considering that we are creating a mapping between names and dates, it is entirely a... it would not be a bad way at all. It wouldn't be a bad idea at all to use a dictionary to do this, right? Dictionaries are our data structure for mapping between two different data types of, arbitrary type. So, self.dict is a blank dictionary. We'll start with a blank dictionary. So, let's do add first. So, def add. Well, you know what? No, let's just put our prototypes in. And then we can fill them in. Def contains self name def clear self and def birthdays self date, and add needs name and date, and there you go. We have all of our prototypes. So clear is really easy, so let's just get it out of the way. That's just reinitializing the thing to a blank dictionary, right? So you have a couple of options. You could just copy and paste this line, or you could also do bdays.init. Self. So if you call the initialization function, instead of just resetting the dictionary, then if later on you want to expand this birthday calendar to add functionality to it, you don't have to worry about making all of those changes in 2 places. You only have to worry about making the change in 1 place, because this guy will automatically, because you're referring to the init function, anytime this, anything that you add here will automatically be added here, because that's the way functions work. Let me see if things haven't screwed up yet again. Okay, we're still good. So, we now are presented with a choice as to the particular manner in which we want to store names and dates. Basically, we've got a decision to make. Are we going to make the names into the keys, or are we going to make the dates into the keys? So, depending on which of these we choose, we're either going to make contains more difficult, or we're going to make birthdays more difficult. Sort of one becomes easy and one becomes difficult. Contains, roughly speaking, just checks to see if a particular name exists within the calendar. So if you make names into the keys, then you can just, it becomes a one-liner. Return name in dict.keys, right? Bing, bang, boom. For birthdays, if we make the dates into the keys, then the birthdays function becomes trivial. What we would, if we were going to do that, we would be mapping dates to lists of names rather than just a single name, which, because you can't have multiple keys. You can't have the same key multiple times within a dictionary, right? So you would be, rather than creating a new dictionary entry for each name that has the same date, you would be having multiple, you'd just be plunking these names into a list that the dictionary entry was pointing to. So one of the questions that you sort of come up with is, what is the more unique value between names and dates? If names, which is less likely to be repeated? And I would argue that names are far less likely to be repeated than dates. There are only 366 possible birth dates, but there are well more than that number of possible names, especially if you do first name, last name, or, that sort of thing. So, for now, let's make the dates themselves into the keys. Let me just see if things are okay. Okay. So, in order to add to the dictionary, we need to check to see if the date that we're requesting already exists, right? So if date is in self.dict, then we do something. Else, we do something else. So if the date is not in the dictionary, then we want to add it to the dictionary. So, and that's relatively straightforward. Self.dict at date is equal to name. Bing, bang, boom. We wanted it to be a list, didn't we? There we go. So, otherwise, self.dict at date is equal to our I think dot append would work here. Name. So the append function just adds something to the end of an existing list. So there we go. Now, to see if a particular name is in the list, this is the one that we've decided to make more complicated. So we, of course, don't know if a name is at any particular date, right? So we have to search all of the dates in order to see if the name exists or not. For date in self.dict, remember this loops over the keys. Self.dict, double for loops for person in self.dict at date. If person is equal to name, return true. And if you manage to get through all of those loops without returning true, return place, by which I mean false. There we go. And of course, to get all of the names that are associated with a particular birthday, all you have to do is return what's stored at that key, right? So return self.dict at date. There we go. So let's see if this bad boy compiles. Although it won't unless we actually use it, because this is Python. So let's say B is a B day, B days instantiated instance. So b.add. 02 12 1988. Your lovable prof. B dot contains. We want to print the results of that one. Does it contain your lovable prof? Print B dot birthdays. This guy. There we go. Topic 8.py. False. Traceback. Whoop. Key error. Okay. So we have a bug. What do we do when we have a bug? We print stuff to see what the internal state is. So let's print this thing and see what's going on. Aha! Somehow, some way, our names and our dates have become reversed somehow. Probably because I'm adding them in the wrong order. So, yeah. So that's user error on my part. I put date second and name first, but here I put name second and date first, so I'm just gonna have to switch the order of those. I don't make mistakes. What are you talking about? There we go. So, things are added to the dictionary correctly. Contains comes out true. Your lovable prof is what is pointed to by that date. Very good. And, of course, you should have some negative test cases as well. So let's see if Attila the Hun is in our... Nope, he's not. Poor Attila. Just not in our dictionary, not in our calendar. We do not recognize his birthday. So, let's see, are we good? Still good? Yeah, okay. I think it's spelt with one L, actually. So there we go. Let's see how we did. Ah, well, they include a docstring, which of course you should always do. So we've got init, we've got clear, add. They've decided to use the names as the keys. Controversial. And notice that you can include docstrings for all of the methods contained in a class, not just the class itself. Extremely useful to know. So, because in this case they decided to use the name rather than the date as the key, the contains operation becomes very simple, and the look up all of the birthdays with this date operation becomes more complex. What you in essence have to do is you have to accumulate a data structure that contains all of the values that have that. You look through all of the entries in the dictionary. When a value matches the date you're looking for, you add that key to the data set, and then you spit that back out again. And of course, they've got something that wasn't actually asked for, a string conversion method. Good. Are there any questions about that one? Can I get a thumbs up? Cool. All right. So let's move right along to the mean calculator. So our task now is to design a calculator for arithmetic mean with the following two operations: add and mean. The mean should account for the same number being added multiple times. All right. Thank you, folks. So, let's begin a new class. We'll call it meanCalc. Inherits from nothing. We want to automatically put in our initialization function. Method, pardon me, takes self and nothing else will initialize to 0. So, once again, we are confronted with the issue of the manner in which we need to store our data. So, let's put all of our data into a list. Self dot, let's just call it capital L. Give it emptiness. Add our function prototypes. We want to be able to add stuff to it. And we want to be able to see what the mean is. Self, and that's it. So, if we want to add something to the list, that's relatively straightforward. Self.list is dot append whatever n is. And if we wish to calculate the mean, very simply, you just return the sum of self.l divided by the length of self.l. Very, very good, very cool. So, if we create a mean calculator, m.add 7, m.add 8, m.add 8, print m.mean then we get 7.666666666 all the way to infinity, which is the correct answer. There we go. Cool. That was easy, right? So far, so good. Oh, I have a question about the birthday dictionary. Let me address that question about the birthday dictionary. In this case, there is only one birthday dictionary. How could you have a second dictionary of birthdays independent from the first? Well, quite easily. You would just have, you would declare a second one, B2. If you declare a second birthday calendar object, it does not share information with the first one. It doesn't share anything with the first one. If you want to add stuff to B2, you have to call add on B2. And so that makes it completely separate and distinct. So there you go. Good question. So, let's see how things are handled in the slides. And it's more or less how you would expect. This is like the other way of appending, which is fine. But yeah, we pretty much hit the nail on the head here. So here's an idea, though, because that's not the only way of calculating the mean. In fact, one might say it might be a little bit memory inefficient, because these where are we? Here we go. Right now, everything that is ever entered into the mean calculator it's all stored, and then when we want information out, we sort of process the information. This is like, generally speaking, when you're dealing with object-oriented programming, you've got two main ways of doing your data processing. You can either do it as the information is being input or as it's being output. In this particular instance, the data processing part is being done when we call for the output. This makes it faster to add stuff, but slower to read stuff. So this is possibly the sort of thing that you would want to do if you add stuff frequently and read stuff out seldomly. So, but we can do this in a different way that is more memory efficient. If we use the observation that we don't actually need to hold every single individual value, all we need to know is what the sum is and what the length is. So we can keep running totals for sum and for length, and then we don't have to worry about it. So if we've got self.s and self.l, that'll be sum and, well, it doesn't have to be length. We'll call it n. No, we can't do that. Count. Initialize both of those to 0. When we add something to the mean calculator, self.s plus equals the value of n, and self.count plus equals 1. Therefore, when we return stuff, all we have to do is self.s divided by self.count. See how we never have to actually even touch complicated data structure. We're just keeping track of things as we go. So, if we execute this, you can see we get to exactly the same position that we were at before with a fraction of the memory, which is good, generally speaking. But there is a trade-off. Oh, I've got more questions. What if, okay. What if you wanted to make n a list of integers? Would you still use classes then? Yeah. Oh, that's a good question. Actually, let's just do that. So add def add many. We can easily expand our definition. So let's call it capital N for a list of n's. So for n in n, And then you basically just copy-paste this stuff. Actually, you wouldn't even have to copy-paste it. You could just do mean calc 2 dot add n. Bing, bang, boom. Very, very quick and easy. Would you ever have to take information from two objects that use the same class and put it into one structure? Like making a list of birthdays from B and also from B2. I mean, that's a perfectly valid operation. So, yeah, here's an idea. Def join bdays. Take self and other. This will compose. This will make a new birthday calendar that contains all of the elements of the of two other birthday calendars. So, or maybe we just want to add them all to self. I think adding them all to self would be fine. Adds all entries in other to self. So then for date in other, for name in other dot date, because remember, it's we have to loop over both of those. Self dot add date name. And I think that'll do. We can check that. So b2 dot add I don't know when Attila the Hun's birthday was, but I'm going to assume it was April 18th. Like 1305? I don't know. I think he was earlier than that, actually. He was like 805, something. I don't know. So, then if we... Oh, I still have a print statement kicking around in there, don't I? Let's get rid of that. Or let's not, actually. Or better yet, even better yet, let's define a print function. Def string take self return string convert self dot dict. There we go. So b dot join. I'm just going to call it join. B2, print B, let's see what we got. bdays object is not iterable. Other dot dict, there we go. No attribute date. Dict at date. I'm getting sloppy. There we go. And there you can see we now have both entries in... Oh, except, of course, I've messed things up yet again by putting the date first. There we go. Ta-da! There you go. Good questions. You just tried add many and it doesn't seem to work. All right, let's try it. m.add many, say 9, 4, 5, 6, 2, 3, 4. Ooh, Missing one required positional argument n. On line this one. Oh, yeah, just include self. Because we're referencing the class name rather than an object, we have to include self, right? We have to use the full argument list. So there you go. Ta-da! Cool. So, mean calculator 2 is, you know, in the manner that I specified. So, the idea behind this little quiz is that if you're just using the class from the perspective, of a person who's just using the interface to the class, they can't tell whether the class is using a list to keep track of this, or they're using this counter method. And they don't need to. If the class is doing its job correctly, you don't need to know how the data inside of it is being stored. All you need to know is what the methods are and what they do. This is, once again, building into our idea of abstraction in programming. Modularity. Black box testing. So, classes can be used without needing to know the data structures of the implementation. The documentation refers to abstract data structures that may not be present in the implementation. So, you know, I often ask this question of classes, and they're like, oh, well, you could probably tell by the memory usage. And it's like, yes, you can distinguish a more efficient algorithm by the fact that it behaves more efficiently. But with respect to the manner in which it's used in code, there is no difference. So, there you go. Let's see, what do we got? A little bit. All right. Okay. That last bit at the end is just kind of a thought experiment that we'll do at the end. But anyway, so it is possible to further the cause of data policy and data abstraction by making certain members quote-unquote private. So if we make those of you who have worked in other programming languages probably know the difference between public and private variables. But essentially, when it comes to a class, if you make a attribute private, that means that only methods of that class may access it. So, for example, if I were to make S private by adding 2 underscores in front of it, that's how you make something private. Then if I tried to print m.s directly, I would get an attribute error. It would tell me that it has no attribute s, despite the fact that if I show you what happens in mean calculator 1, which has no such modification, it's really not defined. Oh, mean calc, just regular. There we go. Oh, it's still, come on. It doesn't have an attribute s. All right, so just imagine, poop. All right. If I remove the tag, then you can just view the sum. And if I have those underscores in there, you cannot view the sum. You can't view it, you can't modify it. Python pretends it doesn't exist because it's private. So, the purpose of that is if a user has access to all of the variables that you're using within a class, they can use your data in manners you did not intend. if the entire purpose of your class is to enforce a data policy, which it should be, you will want to, as part of that, restrict and control the manner in which the data is accessed. So, making members private is a manner of actual enforcement. Before this, we haven't really had much in the way of actual enforcement. Incidentally, the way that Python requires you to put 2 underscores in front of every single instance that you call this variable is just another demonstration of why Python is the most terrible programming language. Well, it's not the most terrible programming language, but it's, you know, it has its annoyances. In a normal programming language, you would just declare, like, up at the front, private int s, and then that would take care of everything forever. You wouldn't have to do these. You wouldn't have to physically modify the way in which s is written each time, which is frustrating and stupid. And if you forget it somewhere, it'll create another non-private one, I think. So, yeah. Anyway, let me know if you have any questions. Any? Oh, by way of announcement, I'm moving my office hours this week to Friday. I have a thing which conflicts, so I'm gonna have to move it to Friday. Hope that's not too inconvenient for everybody. Shouldn't matter too much as it's not a test week. Can you see the cat? Yeah, I could go find the cat. It's not hatred. It's constructive criticism. Just learn C++. That's all I'm... Just learn a real language. Everybody, please. Take your Python knowledge and apply it to something real. It's okay. Python's a good language for, you know... It's a good language for getting into programming, but... you know, there's this famous saying that Python is every programmer's second programming language. I'm gonna go grab the cat. Here he is. Whoa, come on. Say hello to the people on the internet, Martin. I just woke him up, so he's all smushy. Yeah. Aw, he's purring. Like, my problem with Python is kind of like... It's like the overprotective ant of programming languages. Like, it does everything it possibly can to protect you from the way that your computer actually works. Which is, like, kind of ridiculous. It's like, the reason I say overprotective ant and not overprotective mother is, like, because... I don't know, with the overprotective, the sort of caricature of the overprotective ant, it's like overprotective without having any right to be, you know? So, yeah. Because, like, it's all about hiding you from the, like, hiding the memory management system from you, and hiding how functions really work, and, you know, it's like... hiding you from the fact that data types are a thing. Like, it's just... And, again, it reduces the complexity of the language from the perspective of someone who's learning it, because, you know, if you're just learning a programming language, it's a lot to take in, you know? And, you know, I get that. And it's kind of like... I don't know. I guess, like, fundamentally, I kind of had this attitude towards programming that, like, sure, you're taking an intro programming class, but if you wanna program, then it's like, get serious or get out, you know? You know, it's like, if you think you know programming and you don't know what a pointer is, man, you need to take more courses. So, I hope that through the process of taking this course, everybody who takes this course will realize they'll realize the size of the iceberg of knowledge that they've stubbed their toe on by taking this course. But anyway, I should probably go get lunch. Thank you, everybody, for paying attention today. I'll see you on Thursday.